Here's example 9 for probability. So we can define the origin of a number is defined as so. We can check the sum of the digits of that number to have a new number. And then we can check the sum of the digits of the resulting number to get another number. And then we can repeat this step until you arrive at a one-digit number, which will assign as the origin of our initial number. So let me just demonstrate an example. Let's say 29. We can take the sum of the digits of 29, so that will give us 11. And then we can take the sum of the digits of 11 to get 2. And here we stop because 2 is a one-digit number, and this will be our origin of 29. Now you may notice there is a table right here. So the table below shows the possible numbers form that is less than 100. And here we have the ones digit represented by each column, and then we have the tens digit represented by each row. So what that means is, if we have a space, assume this one, it has a column of 2 for the tens digit, a row of 2 for the tens digit, and a column of 2 for the ones digit. This number actually represents 22. So let me just try another example. Let's say this one right here. This will represent 35 because it has 3 as its 10th digit, and it has 5 as its ones digit. Now the goal is to fill this not by its initial number, but by the origin of its number. So before we have shown that 29 has an origin of 2, so therefore we can fill this box right here with 2. And then you can do this for every single number that is less than 99, and you will be left with a very nice result as shown. Right, so here is the result of the table. And if you notice, for each diagonal, you will notice a pattern. So for every next diagonal, the values will add by 1. So it will go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when you arrive at the 9 diagonal, let me just mark that, the next diagonal will immediately go back to 1. And then it will repeat the add 1 for each diagonal shenanigans. Alright, so that's the result of the table, which I think is pretty nice. Now for part B. According to the table, find the probability that a number less than 100 selected at random has an origin of the following criteria. So let's just answer part 1. So here we can determine how many 8s appear in this table. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 8s. So our probability will be 11 over 100, where 100 is the total number of integers between 0 and 99, both inclusive. Right, for part 2. Now we can determine similarly the number 2's that appear right here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 right here. Oops, yep. So the probability here will be 11 over 100. And you can notice that there are exactly 11 numbers for 1, 2, 3, 4, 5, 6, 7, 8, 9 that appear on this board. So there are exactly 11 ones, 11 twos, 11 threes, 11 fours, and so on, with an exception of 0, which only appears once. So that's also a very nice element or aspect to this table. Now for part 3, the probability that it is at least 7. So here can determine the the numbers with the value of 7, 8, or 9 that appear on this board. So we have these guys right here plus these guys right here. And you can determine that there are 33 of them. So the probability will be 33 over 100. Or you can use the same reasoning by noticing that the number of numbers for each value, with the exception of 0, is 11. So there are 11 numbers for each number. So like I said, there are 11 threes, 11 twos, and so on. So notice that there are 11 sevens, 11 eights, and 11 nines, giving us with a total of 33 numbers. Now for part 4, which is at most 3. So yeah, by the same technique, we can determine the number of numbers from 0 to 3 that appear on this board. And you can notice that there are 34 of them. So there'll be 34 over 100 or 17 over 50. Because notice that there are 11 ones, 11 twos, 11 threes, and 1 0. So that will sum up to 34. For part 5, which is the origin is a multiple of 3, that will be 3, 6, and 9, which occur 33 times by the same reasoning, like the previous two parts. So that will be again 33 over 100. For the final part, which is a factor of 30, we'll notice that we can list the factors of 30 as so. So it'll be 1, 2, 3, 5, 6, 10, 15, and 30. Now the only numbers we need is 1, 2, 3, 5, 6. And you can also check that there are a total of 55 of them that appear on our board, since there are 11 of each number right here. So there are 55 of all 5 of these. Again, we can simplify this into 11 over 20, which ends this video.